does. It was unfamiliar to me, so I checked it and saw that it returned an error.
Yeah, so what is going on here? The function head takes the first element of the list, unless the list is empty, in which case it just crashes your program. Tail takes all but the last element of a list, unless the list is empty, in which case it crashes your program. Init takes the beginning and so on, and last takes the last element, unless it's an empty list, in which case your program crashes. So all of these are partial functions. Give an empty list to any of these and they will fail. Give a value that is not a just value to this, it will fail. This is a list indexing operator. Ask the 10th element of a list that contains only 3 elements and it will fail. So these are partial functions and these are complete functions. So you take the first element of a pair, that exists always. You take the second element of the pair, exists for all pairs. Length, you can compute length of any list you can care to name, or any finite list. You can take the sum of any finite list. You can reverse any finite list. You can map any list, filter any list. You can concatenate any finite lists. So the point here is that these are, one magnitude more dangerous to use. So everything on the left-hand side are partial, which means that if you give them bad input, so you accidentally pass an empty list to head, which means your program will fail. And these things go with humanity, that we are humans. Thus, if something can fail with bad input, this invariably leads to the fact that it will fail on bad input. So if you use partial functions like head or tail, you are making yourself tiny holes that you can fall into and break your leg later. So in most cases, you don't have to use any of the functions on the left-hand side. You can just use pattern matching. If you use pattern matching, make a case statement or handle the empty list and the non-empty list separately, there is pretty small chance that you forget one of these cases. So, at this course, if you use any of these partial functions given on the left-hand side, in your answers, you might occasionally need to use those. You have to put a small comment next to the function saying that, yeah, I can take the head of the list to X because I have, checked that the list is not empty. Or if you are taking a minimum of a list, you have to, sketch a short proof in the comment that the list cannot be empty. And then you run your program, and during this course, if you keep doing that, you will claim in your code that this list will never be an empty, so minimum will never crash. And sometimes you will have a program that crashes. So be careful with these and avoid the left-hand column. So left-hand column, partial functions, you give them bad values, they will crash. Right-hand side, they don't crash, but there is this Turing topic that is always with programming that they might not terminate. So if you give an infinite list to sum, for example, it might not terminate, but it doesn't crash, which is, an improvement. Yeah, and remember, if you use those, put me a comment on your source code file why it is safe to use at this point. So, on the other side of the coin, if you keep diligently doing this, so you use only complete functions, you handle all the cases in all the patterns that you are unpacking, then your program will always work. Can't fail. Although it might not terminate in a reasonable amount of time, might not stay in bounds of the memory of the computer, but that just means that you have too little memory. You buy, 1 quintillion terabytes more and it will work. And, well, it might not do exactly what you wanted. And during this course, we actually, can make some nice guarantees about the first one. We know how to make programs that always terminate. or at least one subclass of the programs. But until we get to topics like co-recursion, that's still off limits. So, I'll give you another piece of code that I wish you to discuss about. So, apart from the use of head and tail, what is wrong with this dstutter implementation? First of all, what is dstutter? It is the exercise I gave you. It's a function that drops consecutive same elements. So if you have list 1, 1, 2, 2, 3, it will give you list that all these repetitions are removed. So 1, 2, 3. Where would you use this kind of function? Well, you of course would use it in some signal processing application where you have a stuttering signal. For some reason, your communications protocol is repeating some values and you want to discard the repetitions. But okay, discuss. What is wrong with this function? This is a slightly more harder